proprietary for the 808. I mean, for the 88 microchips, you know, microchips programming. Okay. Anything? Anything? No, never mind, Jising. Jising, just now it's just a discussions. Okay, so we're going to redo everything, you know, from 5 to 6. Okay, so but from 5 to 6, I'm not going to run the micro MP lab. You type the program and you try at home. Okay, so and let's have a look here. Okay, so again, this is not portable. So remember, if you want to be portable, you should understand pointer. Okay, that's the reason I will introduce a bit of pointer today. Okay, no worry, there's one pointer section towards the end of this lecture. Okay, and there is a lab sections for you to take home to try. Still remember or not, I already created about 15 different labs for all of you to try. Okay, with answer. You know, answer is provided in all these 15 labs. Okay, please try it. Okay, all the questions is already, you know, inside these lecture notes. Okay, let's move on. Okay, so attribute is very useful. Okay, so again, you know, the time when we touch attribute, we also touch something called auto PSV. Okay, auto PSV means that, you know, we are touching something called constant. CONST. Still remember, when we are constant, okay, so when we're using constant got two different function, different application. The first one, when constant apply as a global variable, example. Okay, so when you apply constant as a global variable, constant integer x, okay, equal to something like this, like a lookup table. Okay, means once you have a constant, this lookup table, the content of this data is stored in the program code. By utilizing the pointer, built-in pointer like table read, table write, okay, and PSV, we can doing a switching, you know, migrating to the data memory by using a table read write and table write or table read. Okay, this is what you have learned, you know, in the microcontroller and microprocessor. So, however, if you do not have the constant word, means that all this data is stored inside the data memory. So remember, we have a very limited data memory. Data memory is something that considered very expensive. Okay, but if the constant variable apply inside as a local variable, so this means that this location x equal to 5, okay, x equal to 5 means that a certain memory location which contain 5, I cannot change this. Means I cannot, like I can say x equal to 10. No, it's not allowed. It gives you error. Okay, so constant just like locking that value, it cannot be modified. That particular location cannot be modified. So if you are applied as a local variable, let's have a look. Okay, to give you an example. Okay, let's say we have just now we have tried it. Let's say integer q equal to 5. Integer, just now what did we did? Q2 equal to 10. Let's say integer address of Q2. Okay, and I will put P equal to 0x55 example. Okay, so in C programming, it's a bit different from Python. Okay, so in C programming, whenever we assign Q equal to 5, the compiler automatically assign a memory location for this Q. let's assume, let's say 800, 0800. Okay, I assume this location will contain 5. This is auto assign. Okay, so then at the memory location 0900 example, you contain 10. This is for the Q2. Okay, so whereas address ampersand means address, pointer means point to that address and take the content out. Okay, so in this situation, once we put a P, as usual, the C compiler will give him an address. Let's say 950. Okay, what is the content of this address? Okay, is actually is the address of Q2. What is the address of Q2? Is 0x0900. So this means that pointer P is pointing to this address and take the content out. What is the content of this address? Actually is 10. So this will give you 10. Okay, is it clear? Okay, so let's say the next line, let's change the color. Hope I'm going very slow because a lot of people still got problem with pointer, you know. Let's say the next line, I assign 55 to the pointer P. So 55, which is pointing to the address 0x900, okay, which contain 10, and it will be updated, become 0x55. So automatically, since this pointer is pointing to 0x900 and is being updated to 0x55, Q2, which is pointing to 0x900, also being updated by 0x55. Okay, so this means that we can update, you know, the memory location 0x0900 without assigning something like this, or Q2 is equal to 0x55. Okay, this means that Q2 also suddenly come back. Why my bank account got additional 55 ringgit? I just got 10, something like that. Okay, someone deposit, you know, money to him using a different channel by just get his what I call it, account number, something like that. Okay, is it clear? Okay, if clear, give me a thumbs up. Okay, I hope that double clear for those who already attended. I mean, just try just now. And no worry, class. Actually, you can try this, you know, in your MPLAB X. You type this and you can check their memory location. Like just now, the memory location data is generated. Okay, you can try this, you know, in the MPLAB X. Please try it at home. Okay. So let's move on. Okay, what did I let's say, okay, let's do a bit of updating. Okay, let's move to the next page. Here's the next page. Okay, where is my, why cannot move? Why hang? Okay, let's say what should I do? Okay, let's say okay, now we try to update the same program. So remember just now the integer q equal to 5, integer q2 equal to 10. Okay, so integer pointer p equal to address q2. Okay, so remember, if I apply constant here, what does it mean? So means the memory locations, okay, which contain this q equal to 5 is locked. Okay, you cannot touch it. Okay, same with the q2. Okay, now if I put something like this, q2 is equal to 0xAA just now, so this is not allowed for information. No, it gives you error. You can't even compile. You can try later, you know, using MPLAB X. Remove this, compile, no problem. You put in this, you compile, they give you error. Okay, so that's the reason. Okay, you can't change this location. But however, I told you, you can change this, by just applying this without touching Q2 at all. Okay, is it all right? Yeah, I hope it is clear lah. Okay, let's move on. Okay, let's play with this constant and pointer together. Okay, sometime we have a constant, okay, integer q equal to 5. And class, there's advice for all of you. So please try to understand everything on the spot. Again, don't have a habit such that, okay, it's recorded, it's recording. Okay, I will watch it, tonight. For information, you're not going to watch it tonight. Okay, you watch it till end of the semester, then you create a lot of problem. Okay, please, this is my advice. Okay, so that's the reason, all this lecture, okay, I will also summarize and post it to the Facebook, Okay, so let's say constant q equal to 5, and I say integer constant. P equal to Q. Okay, so what does it mean? So this means that, okay, let's play with it. Okay, let's say Q have a memory address, let's say 800, which is content 5. So P, let's say is 900. Okay, and P actually is looking pointing to the address of Q, like what I told you just now. This should be 0x800. Okay, and the pointer P, you definitely contain 5. Okay, but however you apply the constant, so this means that here, this one, I'll change the color a bit. Why no color, all gone? Okay, now mind. So this means that this is a protected, is a constant. Okay, so that's the reason. If I have another line like equal to 70, so it give you error. Compilation error. When you compile, when you build it, it gives you error. Okay, so it's not allowed. Why? Because it's already protected by the constant. So this phenomenon is what we call as this phenomenon. This line is what we name as a pointer to constant integer. Okay, there's a name for it. You can Google. There are tons of information is coming out. Okay, so you need a lot of patience, to read the article, because it's very, very complex, very complicated. Okay, so but however, can I do something like this? Okay, I put another line here, constant integer q equal to q2 equal to 10. Okay, so then I say p equal to address q2. Is it allowed? Yes, this one is allowed, because the constant only protects the content of the pointer. It's not the address. Okay, however, if we do a bit of updating, let's say we use back the same situation, constant integer q equal to 5, and this round I'm putting in integer constant p equal to address of q. You see the difference between this and this? The pointer is moving out. Okay, the pointer is moving out means this is what we call that is a constant pointer to integer. Okay, so in this situation, the variable being declared is constant pointer pointing to an integer. So this implies that the pointer shouldn't point to some other address. So this means that the address is protected. Okay, What does it mean? The address is protected. So this one is not allowed. Error. But however, this one is perfectly all right. Okay, is it clear? I hope things is clear for all of you. Okay, so no worry. You how to say that? You wouldn't appreciate pointer if you don't use it. Okay, as I told you just now, in future, if you're the embedded programmer, if you're device driver programmer, if you're, or probably you went to Intel, you know, you're under the software team, so I can guarantee you see a lot of pointer. Okay, unless you say, I see, I want Python. Okay, Python do not have pointer. Oh, wow, everyone is so happy. Okay, so remember, Python is more to deep learning, you know, fast. You want to fast, you know, you can't use deep learning, all these things in through C programming. It becomes slow. Become tedious, not slow. Actually, C programming compilation time is faster than Python. Okay, let's move on. Okay, so let's, even though we also can have this, you know, we can have like constant, integer, pointer constant. CO, why cost? Sorry, remove this. Constant, integer, pointer, why? Constant P equal to address Q. Okay, so this means that this one, like 70, is not allowed, is error, and even this also error. Okay, error during compilation. So this one got name for it, is say is a constant pointer to constant pointer. Okay, class, you know why I say pointer is a bit tedious. Sometimes they got a few pointer, triple pointer in a function, and sometimes we got a function call, you know, delay, you know, of a pointer. We can have something like this. So it's much complicated. Of course, we are not going until that extent. You know, if I going that extent, it take another month. You know, you need a month time, you know, to master pointer. Okay, so this is not our job. I just to introduce you got something called a pointer, and remember, pointer is portable. So whatever I teach you just now, I can move it to probably to what I call that, to MCS 51 family. I can move it to ARM microprocessor. I can move it to different microprocessor, as long as they can support C compiler. They can support NCC. Okay. If this is allowed, this is no problem, but not the attribute. This is no. This is not migratable. No. So, and of course, this one, you no need to understand what is pointer, because when you call this function, is do at the background. Okay, is it all right, class? Okay, let's move on. Okay, so you go. Okay, let's have something, you know, to make things clear, since we talk about Python. One first, to keep this. Okay, about Python. Just a brief, you know, why, what happened? Okay, so as you learn, just now I told you, you know, when we create a P, okay, a Q, and definitely we create a memory address 0x900. Okay, so the 0x900 will contain a value, okay, 10. Okay, and if P equal to Q, okay, it can is 905. Okay, also 10, something like that. Okay, so it's fair enough. But actually in Python, okay, in Python, there's no pointer. Okay, so instead they create a Py object. Okay, So he set the value to this pi object. Let's say p equal to 10. He set the value to this pi object. Just to let you know lah. Okay. Then they also got something called a reference count. Okay. So how this thing work out? Let's say, for example, p equal to 10. Okay. So you create a what I call that a pi object. Okay. And he said that, oh, it's an, let's say it's an integer. Oh, it's an integer. So the value is 10. Okay. So the reference count, okay, it is 0. Okay. So this time it is. So then suddenly I say p equal to q. It's very simple. They just link this, to q. Okay. Sharing the same object, but the reference count probably just a different number, 1 or 2. Okay, so these are the different, between C programming and Python. So Python is much straightforward, okay, and you're not going to very low level. Okay, so that's the reason you found that Python is super easy compared to C. Okay, for your information. Okay, that's the reason like you dealing with something very complicated like deep learning, like neural network, or all these things become quite straightforward. You don't need to go until low level, so low level. Okay, let's move on. Okay, so some other very simple thing in C programming is this directive include, define. Define is very useful. Sometimes like LED, you assign LED to, like, for example, you assign, I want to use RB0. RB0 actually is connected to the LED 0. So now you know what is RB0. But then after 10 years, you take out your programming. If you have a bad documentation, you don't know what is RB0. So if you define properly LED 0 is like RB0, then things will be well organized. Okay, it's well organized. And sometimes we got something called directive. If defined, without end. Everything is end with if. So if this thing is not defined, he define for you. Like for example, still remember in MPLAB X, like here. Nothing come out. Oh, gone. Okay, let's see. If defined, then you include this. Now I'm using PIC24 FJ64 GS002. So definitely, only that particular processor is activated. If I define this, only this will be activated. Okay, is it clear? So this is how we write our C programming. So that is more professional. Now, if not defined, then you define now. Okay. So this kind of writing is more professional. When you do something like this, you're like a professional programmer. Okay. Where is it? Okay, let's move on. Okay. So in certain situations, we also need to combine, external, volatile. Okay, I will talk about volatile later. This is a very interesting reserved word. Okay, it used, in almost all the C programming, embedded C programming. So now I want to extend means that this port A, it can be declared any way, in any .c file. Okay, attribute means that I'm touching the memory location by assigning a special sections, as a special function register to define port A, where port A is stored. Okay, so this means that if I say 0x1234, this is stored in a special location with all the special function register memory located. Okay, so human can understand what is port A, but for the compiler, actually this port A is situated as a very special location. Okay, so but this is the way they declare their special function register, or you also can declare your own special function register if you have. This is actually everything is over here. External volatile, how you declare, is over here. Okay, why volatile is important? Before I look at volatile, there's something that shortcut. Okay, so you can type something like this: port B bits. When you press the dot, the RB, the one whole table is coming out for you to choose. The shortcut is just put underscore. So I prefer something like this. It's more neat. Okay, it's neat. Okay, just underscore RB5 underscore RB2. Remember, this one is just apply for microchip only. Okay, and always remember, embedded system design is the mission is not to learn microchip. We use microchip as a platform. Okay, as a platform. This is very important. Okay, let's move on. Let's look at what is volatile. Still remember or not? We discussed such that, wow, we need something that is optimized. The code optimization, wow, very good. I like code optimization. When code optimization, my code size will be reduced, will be faster. Okay, but it indirectly they create a problem. Okay, let's look at the problem. Okay, so these are the problem. Okay, so as you know that when we do memory and register, which one is faster? Definitely is register is faster. Am I right? If yes, give me a thumbs up. Oh, no, it's no. It's memory is faster than register. Okay, so that's why when the code is optimized, they like to use register. They only store back the content of register to the memory towards the end of each section of the program. Okay, let's have a look. Okay, if this code is optimized, optimize. Okay, and no worry, your code is not optimized, but you worry when you go to industry because all their code is optimized. So when integer a equal to 1, what is this indicated? Okay, so this means that 1 is stored in the memory. Okay, let's say memory 1. B is stored in memory 2, special memory location, like I told you just now. So when you come to, let's say this is test function, character Y. So for your information, if the code is optimized, it's not stored in the memory, instead it's stored in the register. They only update, into the memory towards the end of the program. Let's say printf. So this means that the memory 2, you move into, let's say R3, R1. Okay, I should use R1 here. Doesn't matter. Memory 2 going to R1 is memory 2. So this is this one will be register is equal to register plus 1. Register 2 equal to register 1 plus 2. Okay, and finally, eventually, they only store back, the memory. Okay, the register of R2 will go back to the memory. Okay, it looks perfectly all right over here. But however, look at my cursor. However, if there's an interrupt occur here, after the printf, okay, remember what is B after the printf? B is 1. After the printf, you interrupt occur, it come to the interrupt. Where's the interrupt? Oh yeah, my cursor. Come to the interrupt. So remember, over here is an interrupt. So what did they do? R1 minus 1, B minus minus is B equal to B minus 1. So it's stored back into the memory. So you're coming back to this, when he returned to interrupt, he didn't update the register, but instead he updated the memory. So in this situation, error. This error is very, very serious. Why is serious? Because you don't know when interrupt occur. So for student, it will say sometimes can, sometimes cannot lor. Because if interrupt is didn't occur, it will work perfectly. You're so happy. If interrupt is occur, why it's not working? And worse is you don't know when interrupt is occur. Okay, so that's the reason it's very, very risky. So to solve this problem, I just put volatile, for this integer b. If I put volatile for this integer b, why I can't change my color anymore? Never mind. So if I change to integer b, so everything involved here is no longer register, but instead is a memory. We're not involved register anymore. It's a memory. No, R2 is still register. Sorry, R1 because we declare this, for memory 2. Okay, this R1 is all is memory. Okay, so this is a memory. Okay, you as a designer know which variable should be declared as volatile because you design the code. You know that something in the interrupt, then you know that, oh, this is very important, I should declare as volatile. No worry, as a student, you don't care because you are not using the paid version. You are using a student version. There's no optimization over here. Okay, so is it clear? Is clear? Give me a thumbs up again. I know all of you are very tired this weekend, Friday and Thursday night. Okay, so any questions? Okay, let's look at the chat box. Is this you still got any problem or not? Okay, I hope everything is perfectly all right. So I hope all of you are following. Okay, well, so it's not difficult. Okay, let's move on. Okay, so gender reminder. So it's good to understand the concept. Slow, it doesn't matter. I'm going very slow. So if you got problem, please message me. In the class, you ask your neighbor. Now no neighbor due to COVID-19, just PM your friend or you have a group discussion through Microsoft Teams. And remember, don't accumulate again. Don't say that I go home tonight. No, tonight I can replay the video. You won't replay it. It's very boring. Okay, I know that. How many of you really replay my video? Yes, 1% or probably 0%. Okay. Okay, let's continue. Okay. This one, unsigned integer. Okay. So sometimes you feel like you see, class, for your information, this is very important. Unsigned integer. So this means that if unsigned integer for 16-bit microcontroller, the total location is 2 bytes, means you can store from 0 until 65535. Okay, 16 bits. If this is an integer, so it's just like negative 3276788, until positive 32767. Okay. So, but in a lot of situations, we don't involve negative value. So remember or not? So that's the reason microchip. I'm not sure the latest version. Those 10 years ago in microchip, you need to type unsigned integer. Later, they change it. It's found that not many people are using negative value because they're using second complement will do. So they update it. Whether you put unsigned or without unsigned, it still support 0 until 65536. There's no negative. Okay, but this is not the case for other microcontroller. Please, be reminded. Okay, so let's say to type unsigned integer is very boring. It's too long. You can always have to do something like that. Type define unsigned integer become unit 16. This can be any value that you can understand. So then you can do something like this. If you're lazy, you just do one time untype define. No need to type so long. I don't know. Okay, it's all up to you. Okay, there's another reserved called persistent. Okay, when I assign persistent to this variable, okay, to this variable. Okay, when the system is reset, okay, whatever you store over here, the data is still preserved if you do persistent. So again, this is the depend on the electrical characteristics of the microcontroller. You can try it. So how to try it? This one you need to try it in the hardware. You don't have the hardware. Okay, so just to let you know that persistent actually is to preserve the data when upon resetting. Okay, is it all right? Okay. So if nothing is being declared, is initialized, normally it's 0 lah. So let's move forward. And then this is your first program. Okay, you can try lab 1. Okay, in lab 1, you basically talk about just like what I told you. Unsigned child is from 0 until 255 is 8 bits. Please be careful when to use child, when to use integer. Okay, so let's say your data is just ASCII code. ASCII code, you don't need 2 bytes. All right, no, you don't need integer. Okay, so this one will help you to save the memory space. Okay, integer, instead of character, if you use integer, your space is double, more than double. Okay, so if your data is not exceeded 8 bits, please use character. Okay, is it all right? Okay, so there's a lot of definition. If long, if you got a lot, the data is very large, then you use long, sign long. This one you can go through it lah. And as well, we have floating point, we got double, we got long double. So class, remember that day those who attended computer architecture, you I don't know what platform you are learning during your lab. So if you're using 32-bit of microcontroller or 64-bit of microcontroller, character is still 1 byte. Short is 2 bytes. Integer actually is 4 bytes. For 16-bit is 2 bytes. Is it clear? Long for what? For 16 bits actually it's just long is how many bytes? Is 32-bit is 4 bytes. Okay, it's 4 bytes. Okay, so but for 64 bits actually is 8 bytes. So the different size of microcontroller or different size of microprocessor. Okay, so the declaration is different. Okay, the size is different. Okay, so you can try this as a homework. This is very interesting. You just import and try it. Okay, probably you want to have a look how I do it. Okay, so I just demo one for you. Okay, there's a lot of let's say come back to the where's my micro class. I'm not going through all the lab because this lab is for you, to go back and try. So basically all this lab is written using C30, the old Microsoft IDE version 8. So that's why you press this and browse. Okay, so these are the lab. Okay, so remember these are lab given to you. They got not 15, 18 labs. Okay, so class, I didn't ask you to try all the 18s. There's something that you're not familiar with, like structure, union, pointer. Okay, then you can try the lab. Like this one is very simple. Let's just click this, open, next. Okay, and then you don't need to do anything. You just need to put simulator. Okay, and the microcontroller used at the time is PIC24FJ128 GA010. 128 means they got 128 pins. Next, and just click this, next, and then no need to do anything. Okay, the lab one already exists. Okay, just next. Okay, so finished. That's why I don't like microchip. It's a bit slow. Hey, where is it? Where is it? Lab 1, lab this one. Okay, I set it as a main program. Where is it? Okay, main project. Okay, so say main project. So these are the source file. Okay, so class you see or variable, what is the size, constant. Class is got printf. So class, remember printf is tied to standard input output.h. So normally it's not recommended to use printf because once you use printf, it's consume a lot of memory space. Okay, but however, big 128 have a big memory space is perfectly all right. Okay, okay, so so in order to activate a printf, you need to activate the UART. So that's the reason you have to go to the Spana here project. Okay, simulator UART. Make sure it's enabled. Okay. So I debug the program. So the input output window is automatically appear once you enable the UART just now. Okay, so let's say I run the program, so UART output is coming out, it tell you, oh, character is 1 byte, short is 2 byte, long is 4 bytes. It's okay, so this is very simple experiment. Okay, so let's come back to this. Is this the lecture just now? Yeah, okay, please try this lab. There's 18 labs over here. Okay, blah, 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 blah. Okay, let's have a look of this to test your understanding. Okay, show me your answer. So what happened with this code? Will this count plus plus executed? Yes or no? Is there a difference on constant and persistent? Kai-Chin, persistent means, yes, a big difference. Persistent means once you shut down, once you reset the system, that particular variable will be preserved. Constant, we don't, once you shut down the whole thing, the variable being stored will be disappear as well because it's stored in the RAM. It's a volatile. Okay, is it all right, Kai-Chin? Hey, my dear, can you tell me, they got two code over here, which one will execute the count plus plus? This one, A, B, C, both also no. Both also no. Both also not executed. Both also not executed. Of course, yeah, A, B, C, come on. Class, are you listening? Or are you lost in the jungle? Okay, this one means complement. This one means invert. Okay, 0x55 complement is 1010. Yeah, 01010101. After invert 10101010. This also 01010101. After invert is 10101010. So AA, if C equal to A, execute this. If C equal to AA, executed this. Is it both also D? Both also executed. Both also executed. Yeah, come on, give me the answer. A, the pink color will execute. Why so quiet? A executed. What is D? Both also not executed. My dear, just now I told you only, if this is unsigned integer, your C actually is 2 byte. It should be like this, 0055. After second complement is 0s FFAA. So this one will not be executed. Unsigned child is just 1 byte. 1 byte ngam is 55. After invert is 0xAA. Yes, this one is executed. Okay, so the answer is B. Okay, not A. What D? Both also executed? No. That's why please be careful of character and integer. It's very, very dangerous, especially some of you outside timer, counter. You put too large, use up memory. It's not enough, you keep on resetting. It gives you a wrong calculation. So you have to be careful with all this. Okay, so let's move on. Some literals. I'm not going through this. We got normally tab stroke F when you type something, carry return. Okay, this is the ASCII code. Okay, define. I told you already. Try this lab. Okay, this is the second lab, and lab 3 you can try. You know, when you have percentage T, you know what it will display. Okay, please try lab 3. It's very simple. Okay, done with my part 2. This is where my video stopped. You know, I already recorded. I will upload into my FB. Okay, operators. Okay, divide by 3. They give you 3. Not the remainder, the result. Percentage means it's a remainder. Okay. Then divide by 3. The remainder is represented by this modulo. Okay. So let's move on. Okay. So there's one situation. Where is it? Okay, let's move on. Where is it? Okay. Let's say, for example, you know, I put it here. If integer a equal to 10, integer b equal to 4. Okay. So even though I put float c, okay, then in the program I say c equal to a over b. The answer will not give you 2.5. Instead, give you 2. Okay. Remember. Okay. So if you want to have 2.5, you should do like this. So c is equal to float a divided by b. So then you get 2.5. So you need to put a float in front, even though you declare the float over here as c as a floating variable. Okay, you need to put a float in front. Why? Because integer divided by integer should give you back integer. Unless you put 10.0, 4.0. Okay, probably he give you 2.5. It depends on the nature of the compiler. Okay, you try on XC16, XC8, see whether it give you 2.5 or not. If you put 10.0, because you declare integer, it might give you error or give you warning. So I'm not sure. And remember, this one is wrong. You cannot do like this. No. Okay, this open and close should be under the float. It's not this. No. It's like this one is like multiply. You know. Okay. No. Okay. No. So here are the what I call that, the implicity from character. The longest actually is long double. Okay, just move on. And then operator. Okay. So 8 divided by x actually is an integer. This is the modulus. So 8.0 it give you double. So give you integer. When you got L here, it give you long result. Both is integer, give you back integer. So they give you integer. If 8.0 of x might be double because 8.0. Okay, you check. This is also depend on the types of the C compiler that you are using. Okay, so you know x plus plus means incremented by 1. Plus x incremented by 1, then use x. This is use x, then incremented by 1. Do you know what I mean? Okay, let's have an example. Where's my pen? Okay, if x equal to 5, y equal to x plus 5. Okay, what is the result of y? Actually, the result is 10. Okay, if this is a y equal to plus x plus 5, the result will be 11. Okay, one is use first, then add. Okay, use the x, then increment. Okay, and vice versa. Okay, so sometimes you use plus equal, actually is the same. This is the definition shortcut lah. So this one is a XOR gate or shift to the left, shift to the right. Okay, I don't think so. They got a reserved word for rotating. So you need to call a function to perform a rotating features. Okay, so class, any questions till now? Any questions? If no question, we will move forward lah. Okay, so this is clear lah. So remember just now, always student make mistake x plus plus, but what is the value of x? X is still 6 . What is the value of x over x is still 6 . X is not changing, but the using time is different only. So this one is not used. X plus plus is still 5 plus 5 is 10. Okay, okay. Use x then increment by 1. Okay, remember, but the value of x still remain the same. Okay. Oh, this is x greater than less, greater and less, all this thing, no problem. This is equal. Okay, this is a comparing. There's a difference between x equal to y. This is similar. This is compare. Okay, is it x equal to y? And this is not equal. Okay, it's different. It's different from this. This is a first complement, invert, negate. Okay. And this one is a logical and compare is x. There's a difference between AND gate. This is a gate. This is a gate. This is an AND gate. This is an OR gate. This is a XOR gate. Okay. This is an inverter. Okay. This is just a compare logical. If it's x and y, x or y, okay, it's not logical. This is logical. It's two totally different. This is give you false or true only, but this one is really change the content of x and y and give you a result. Okay. So I know this is a different. This is a if x and y then give you the result whether true or not. Okay. This is the okay. Please differentiate between the logical and bitwise. Logical is just like compare if x and y, if not equal to x, then you perform something. Okay. So if then else, no problem. I believe all of you know if this is true, if x greater than y, then do something. Okay, it's very straightforward. So this is a portable language. It's applied to everywhere. So same if x greater than y, x plus plus, else y plus plus. Okay, so this is another simple C programming is applied in everywhere, even in Arduino, even I think in Python is almost the same. Okay, so that's why if you're good in one language, it's perfectly all right for you to migrate, to other languages. It's totally no problem. So they have a lot of is else statements. Okay, if true, else this, or else this, a number of else. Okay, so we can look at the flow chart here. If this is true, then do this. It's true, then do this. If no, then you do the end. Okay, it's not a problem. Okay, example, if frequency is greater than this, and remember, this is not AND. This is an AND gate. This is a gate. No, this is a compare. If this is a AND with this, then we are 2 meter. Okay, 2 meter band and so on. So it's very straightforward. Okay. So then we have try the lab 5. If you are not sure, a very interesting if-else conditions in lab 5. Okay, so switch case is very, very useful, especially when you come to keypad. When I press 1, I do this. When I switch keypad, when I press the keypad, I press the key 1, I activate this. It's just like, you go to the ATM machine. At the very beginning, he gives you a touch screen. Or we press 1, press this button, you're doing this. So same. So at this position, if you press your your position into that particular touch screen. In that position, 2, you print out this, then brick. Case is brick. Brick means it's exit lah. It won't go to the next line. So you keep on, by default, if all this thing is not happening, you printf, will display no signal available onto the UART, onto the serial port, okay, window, okay. So we also have this is a flowchart of switch case. So every time brick means it's just exit lah. For example, switch letter, if the case is A, then letter is A is found, and so on. Okay. So, and sometimes if you got more than few selection, you can have a triple dot. If case 4.7, then you apply this. 9.12, then you apply this. So this triple dot is also depend on which C compiler you are using for information. Okay, for the standard C compiler is perfectly all right. The triple dot from 4 until 7. Okay, so just move on. And we have lab 6. So during the weekend, if you're free, please try lab 6. Okay, for statement and while statement is very, I think most of you already quite familiar with this. For x equal to 10, x less than 20, x plus, and you perform something. So x, every time coming in, if x is less than 20, then you x plus and perform some action until x is if more than 20, he will exit the loop. Okay, something like that. Okay, this is a expression I plus, some of the expressions tree, and this is a statement. Okay, so this is a for loop. Okay, I believe most of you are quite familiar with this because this is a universal language. Okay, while expression, while this is true, then you do something. True or not true, while condition, while x equal to 3, then you LED, you toggle the LED 0. Okay, you toggle the LED 0. Okay, then so it's okay. So or you have a do while statement, do this. Okay, do LED equal to LED, toggle LED. Okay, then you are okay, while x equal to 5, something like that. Okay, so you can get another statement you can write. Okay, the way of writing on it basically. So loop. Okay, well, for example, like I less than 5, then you print this. Okay. So same, do this while I less than 5 is the way of writing. So for the while loop, you can try lab 7. Okay, so this is a lab 7, the flow chart of lab 7. Please look at the lab 7. These are the questions, for lab 7. Okay. So function, definitely function is make your program to be more organized. For example, if let's say function maximum, if return x greater than y, I hope that you understand this. Okay, if x greater than y, then you return x, or else you return y. Okay, so this is not a good way of writing because you use up one memory location, although both function is work perfectly all right. But however, this one they use additional variable. Okay, so basically it's just when x greater than y, you return x, or else you return y. So if then else, okay, this is what is going on here. Okay, you may try lab 8 if you're free. Okay, so this is a lab 8 got a questions down there. You can just go through it. Okay, so so external and static, I believe you already quite experienced with it. I already explained to all of you. Okay, this external and static is at lab 9. You can try it. Okay, So, okay. I think we stop here today. We stop at array. Okay, we continue array, on Monday. So, any questions from the floor? Any questions? I hope that I'm not going too fast, because most of the thing you already learned. Okay, any questions? Any questions? Or you already lost in the jungle? I will stop the recording.